Hello everyone, welcome back to my YouTube channel. So in day 13 of AWS series, today we are going to understand the concept of network access control list in AWS Virtual Private Cloud. Then we will see a difference between ACL and the security group. So let's understand. So what is a network access control list? So basically network access control list is an optional layer of security for your virtual private cloud that basically act as a firewall for controlling the incoming or outgoing traffic in your of subnet basically. So network access control worked on subnet level and security group work on instance level. For example, EC2 instance, if we want to allow or deny any traffic to the EC2 instance, for example, in that case we use security groups. So whenever any traffic come from the internet gateway, first it will go to the network access control list. Once it sees like it see okay, the traffic is allowed in network access control, then it will go to your security group, and from there it will go to your instance, like whatever it is, EC2 or any other services you are using. That's how basically traffic flow. So network access control list basically provide you additional layer of security at subnet level where you can allow or deny the traffic. So NACL are stateless. What does it mean basically? So whenever you create any custom network access control list, by default the traffic will be denied. You have to explicitly allow the traffic if you want, otherwise it will restrict all the traffic. So as we know, whenever we create a any virtual private cloud or custom virtual private cloud basically, then we get few things by default like security groups, and then we got network access control list. So on that basically the traffic will be allowed, but if you are creating a custom VPC, in that case you have to explicitly allow the traffic, otherwise all the traffic will be blocked. So we will see in a demonstration after maybe after 5 minutes maximum, so you it will be more clear then. And one more thing, in network access control, the rules like the route, basically the traffic rules which we define, that worked on a basically numerical basis. Suppose you have specified port 80 on 100 numerical value, and then you have allowed the traffic on port 80, and another rule you have created at 200 level. So the 100 level rule which you have created, that will have most priority. Once it pass that, then it will go to the 200, 300, 400 level. So it basically work in a sequence. So that will also be see in a demonstration how basically the rules prioritize work. So basically the evaluation of rules work on rule number. Like if the rule number is small or sorry lower, then it will have a high priority. Like basically it will evaluate first that one, then it will go to the another rule number which we will specify. Now the question is, where are ACLs used? So public versus private subnet isolation. If you need a segregation in your network, like you want public subnet and private subnet both in different uh, list or in a different place, then you can use network access control list. So you can allow or deny traffic based on your requirement. So generally for public subnet, we host our web servers, so definitely we need to allow the traffic on a public subnet. But in private subnet we generally use or to store our or create our databases and all. In that case we don't want any public traffic, so that's how basically we use ACL in private and public subnet segregation. Blocking specific IPs or IP range. So network access control allow explicit deny rule, unlike security group. So in security group we don't have a deny options. Either we have allow or by default it will be restricted. Additional layer of defense, like defense in depth. because even when security groups are in place, NACLs add a second layer of control, like at subnet level. Now we will see a quick comparison between security groups and network ACL. So if we see scope, so security group we apply at instance level, for example EC2, and network ACL we applied at subnet level. In both security group or network ACL, we are allowing or denying the traffic, but they work at different level. Now we will see stateful. So security group is, yes, it is stateful because return traffic auto allowed until we will not restrict it. But in this network ACL, it is by default is denied. Rules only allow rule is the, like we can only allow the rules. We don't have any deny option, that we will also see. And in network ACL, we can allow or deny rules. Evaluated, all rules are evaluated, and but in network ACL, rules evaluated in order, like in whatever the sequence you are going to create a rules, on that basically it will start evaluating. Now we will see default behavior. So in security groups, it is denies unless we allow, like we don't have option to allow deny the rule, but whatever the rule we have allowed, that will be like the traffic will flow, otherwise by default it will be denied. But in network ACL, denies unless allowed, except default NACL. Use case: control access to instance and control access to subnet. So basically security group work at instance level, and network ACL work at subnet level. So now let's see a scenario here. Security group, for example, we have allowed inbound port on port 80 on at security group level, and same HTTP port 80 we have denied in network ACL. So in security group we have allowed port 80. As for example, here we are talking about a EC2 instance. So in EC2 instance we have created both security group and network ACL, and in security group we have allowed port 80, and in network ACL we denied port 80. Now what will happen? The traffic will be blocked, because in AWS both security group and network access control must allow the traffic for it to be successful. So network access control list are evaluated first at the subnet level, then it will go to the security group level. If something is we have denied an NACL like subnet level, then the traffic will be blocked. If you allow it at security group level as itself, but it will not work, because the evaluation first evaluation will happen at access control list level, then it will go to a security group level. So here I have taken a one image here. So suppose security group basically act as a security guard at the door of your apartment. So say, like for example, this is the building. In building you have one apartment. So security group will take care of your apartment, not the entire building, because you have appointed security group for your apartment itself. But NACL like a security guard at your building gate. So basically this is going to protect entire building, but security group is basically protecting the only instance where you have applied it. So this is the main difference between security group and network access control list. When we will do a demonstration, then it will be more clear. Okay, let me go to my AWS console. So what I will do first I will create a virtual private cloud here. So in each region by default we will have one virtual private cloud. So for example, I am in Mumbai region, then by default we can see a virtual private cloud. In case if I'll go to another region as well, for example I am going North Virginia, so here also we can see by default we have one virtual private cloud. This is why AWS provides us by default. Like suppose if you are not familiar about networking part, then and you want to start learning AWS without the knowledge of networking, in that case you can start utilizing a default virtual private cloud. So and later you can start learning networking part. So let me go back to my Mumbai region. Now the very first thing, I will create a virtual private cloud. Let me hit on create VPC. So here I will give a name, my VPC, let me give 01, and here let me provide a range IPCIDR block 10.0.0.0/16 I'll take here, and rest everything I will keep a default. So let me hit on create VPC. So now what I will do next I will create a subnet for this virtual private cloud. So here you can see three subnets. These three are associated with the default virtual private cloud which we get in on every regions. So let me create a new subnet here, and here I will choose my VPC, which is my VPC 01, and here let me give a name public subnet, and availability zone I will choose Asia Pacific, and here let me give a IPv4 range. So let me give 10.0.1.0/24. So we will get 256 IP addresses as part of this subnet. So let me click on create subnet. Okay, so now we have created a virtual private cloud, we have created a subnet. Now next thing what we need to create, we need to create an internet gateway. And before that, let me do one more thing. Let me go back to my subnet. So because we want a public IP address, so we can connect to our EC2 instance. So let me go to action here, go to actions. Let me edit subnet settings. So here we have an option called auto assign IP. So if I check this option, then whenever I create a EC2 instance, that automatically create a public IP addresses for us. So let me click on this and save. Okay, it's fine. Now let me go to internet gateway. I will create a new gateway here. So let me provide a name, my internet gateway, and let me create internet gateway. Now we need to associate this internet gateway to our virtual private cloud which we have created. So let me attach it, and here I will choose my VPC and attach internet gateway. Okay, so now what next is security groups. Okay, before that what I will do, let me go and launch the EC2 instance. Then the another networking settings we will see after launch the EC2 instance. Okay, so let me provide a name here, my web server, and here I will use image as a Ubuntu, and here I will generate a new key pair. So let me provide a name key, and let me create a key pair, and let me edit the network settings. So here I will choose my VPC, which is my VPC 01, and the subnet, it's automatic taken a subnet because we have only single subnet here. Now here you can see auto assign public IP is enabled now. And security group, we will create a security group called launch wizard 1, or let me rename it web server security group as she. Okay, so by default port 22 is allowed, so I'm not going to enable any port 80 here. So now let me hit on launch the instance. Okay, so EC2 instance has been created successfully. Let me go to my instance, and now what I will do, I'll connect to this EC2 instance and try to install nginx web server. So I'll select this my web server, and I'll hit on connect, and I will take the command this one. So now let me open my command prompt. So I have my private key in my downloads location. So here I have my private key. Let me copy the command and let me run it. Okay, so I have tried to connect to my EC2 instance, but it's saying cannot connect, connection timeout. So what is happening here? Let me go to my virtual private cloud. So here, let me go to internet gateway. It's fine. Let me go to root tables. So here, what we need to do, let me create a new root table here, and let me give a name, my root table, and here I will choose a BPC, and let me create a new root table. So now we need to associate a subnet to this root table. So let me go to my subnet association. So you can see the public subnet is now associated with this root table. So let me click on edit subnet association, and I will choose my subnet here and save association. Okay, so subnet we have associated. Now let me try again. So still it will not work because we have not added the roots here. Okay, so you can see again it's got failed. Okay, connection timeout. So what we need to do, we need to add a root here. So let me click on add root. So here I will allow traffic to the internet. So here I will choose internet gateway, and here I will choose my gateway. Let me click on save changes. Now let me go back and rerun the command. So now you can see we are able to connect to the EC2 instance because there was root missing, and we have not created a root for internet gateway. So this is what we have created for this for this particular root table. So we have associated, like we have basically allowed the traffic to the internet through the internet gateway. Okay, it's working. Let me clear the screen. So now let me run the sudo apt update. Okay, so it's completed. Now let me install the ngns web server. So I will run sudo apt install nginx-y. So now we have installed a nginx web server. So now let me go back to my EC2 instance, and I'll take the public IP address, and let me try to access our application. So it will not work because we have not opened the port 80. So let me go back to my BPC. Here I will go to security groups. So this is the security group we have created, web server security group. So let me go here, and here I will edit inbound rule, and I will add another rule, which is I'll look for HTTP, and source I will select anywhere, and let me save it. Now let me reload the application. So now we are able to access our NGNS web server. So why? Because we have allowed the rule on security group level. Now we will see, like in security group level we have allowed the port 80. So we are able to access our NGNS web server. Now let me go back here and let me go to network access control list. So by default, this is the network control list which is created. So what you can do, you can create a new network access control list. But in our case, we have only single subnet. So I'm going to use this one only. So let me uncheck this and let me select this. So if I'll go to inbound rule, so you can see the all traffic is allowed and protocols. And if I go outbound, so in outbound also it's allowed because this is the default network. So let me do one thing here. Let me create a new network access control list, so that will be give you a more clarity. So here let me give my ACL, and here I will choose my virtual private cloud, and let me create on create network ACL. So we have created a my ACL. Now what we need to do here, we need to associate a subnet on this particular ACL. So let me click on edit subnet association. I will associate my subnet here. Okay. Now if you can see, by default when we create any custom network access control list, all the traffic is denied. And if I'll go to outbound tools, here also we can see all the traffic is denied. Now let me refresh the application. So it will basically time out because we have blocked all the traffic to this particular subnet. So you can see we are not able to access the web application, and we have already allowed the port 80 on security group level. Sorry, let me go to my BPC again. Now what I will do, I will edit this inbound rule. I will add new rule here, and let me give a rule number 100. And here I will choose custom. Instead of custom, let me select HTTP, and here I am giving here allow. Now let me save it. So it is allowed now. Let me refresh it. So still we are not able to access it. Let me go back to my BPC. So you can see a port range outbound rule also we have to add here. Let me add new rule and give a rule number 100, and here I will choose HTTP and destination allow, save changes. Okay, now let me reload it. So here what we are missing. So now let me go back again. Let me edit this rule and let me remove. Okay, this is we cannot remove it. Okay, so here what I will do, add another rule, and here let me check. Okay, so in inbound rule we have allowed port 80, which is allow, and in outbound also we have allowed subnet association, we have already did it. Okay, so this subnet, okay, just give me a moment. Okay, so what is missing here? Why we cannot access the web server here? Because here we are requesting, we are sending the traffic to internet, but as we know, network access control list are basically what is called stateless. So it is not receiving the traffic back. So for that, basically we need to use a femoral port. So let me search here what it is. So it will give, I'll give you, it will give you a quick idea. I'll go to Wikipedia here. So an ephemeral port is a communication endpoint of a transport layer protocol of the internet protocol suite that is used for only a short period of time for the duration of communication session. So here basically from the network access control list, we need to allow the outbound traffic. So we can receive a traffic back to our EC2 or instance or to this particular subnet, so it can access our web servers. So there are specific range for this. So we can use a range called this one, RFC range. So this range basically we have to specify in our uh, outbound connection. So let me edit the outbound connection. So in simple words, you can think it is something to send the traffic back to our subnet. So here I will provide a range here. Let me save it. Sorry, 65535. Maybe a space issue. Okay, so it is. Okay, now if I'll browse our application, so you can see we can access our NGNS application web server. So what is happening? The EC2 instance is in our this particular BPC network, which is my BPC 01. So when a client inside your BPC make a request to the internet, then the return traffic from the server basically come back to this ephemeral port originally chosen by client. So through these port which we have specified here, on these ports the return traffic is coming back to the instance or coming back to inside the virtual private network. And this is like in this particular range, the connection can use, or the request can use any random ports between this range. Once the request will be received, then the port will be dead, so it no longer be available. So whenever again a client raises a send a request, then again it will assign us some random port from this particular range and receive the traffic back to the virtual private clouds, so you can access our application. This is what is happening with the help this is what it is happening because of this ephemeral ports. So this is very important, and you have to keep in mind whenever you are using a custom network ACL, you have to explicitly allow the traffic from internet to VPC with the help of this particular port range. So I hope it's clear. That's all for today. In case if you have any doubts, you can ping me over comments. So see you in next video. Thank you so much.